Good morning students, welcome to mathematics class. In previous class I completed one of the very important lesson, that is probability. Now I will start new lesson, that is chapter number 9, arithmetic and geometry progression. So this is very lengthy lesson and very important also. So please watch the video clips every day, otherwise it is very difficult to learn, especially the lesson like this. So there is a connectivity between one class to another class. Please don't miss. Daily you should watch the video clips. Okay, let's see what about this lesson states that as geometric and arithmetic progressions. Yes, before going to start, first, what is the meaning of progressions? Progression is also called as sequences. Progression is also called as progressions. Is also called as sequence. Yes. Then we'll see the first one, that is arithmetic progression. Before that, you see what is the meaning of progressions. So in mathematics, we have different patterns of group of numbers. Different patterns. So for example, 1, 3, 5, 7, 9, 11 and so on. Yes. So next group. Let's first discuss about this one. Yes. 1, 3, 5, 7, 9, 11. So can you guess the number? Next number? Yes. Correct. 13. Next one? 15. Next one? 17. Next one? 19. So how you are telling the next numbers, I mean succeeding numbers? Yes, that is very important. Suppose, listen carefully here, and in progressions, so these numbers are called as, yes, very important, numbers are called as terms. Very important terms. So these are denoted by, terms are denoted by A1. A1 means, this one means first term. Yes, in this example, first term 1. Next, A2 second term, that is 3. Third term A3 is equal to 5. Fourth term A4 is equal to 7 and so on. Fifth term, yes, that is 9. Sixth term 11. Seventh term 13. Eighth term 15. Ninth term 17, and similarly one by one. Yes, this is very important. Terms are denoted by A1, A2, A3. Now onwards, don't say numbers. Terms you say. Terms. Yes, okay. Na? Suppose last term. Suppose in this progress or sequences 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, how many terms are there? That is A10. Right. So this is the last term in this sequence. So this is called as last term. Last term. There is no terms further 9 onwards. Okay, na? So last term, that is A10. So last term is generally denoted by very important AN or nth term. Last term is also called as nth term. Yes, these are all very important symbolic notifications or denotations. Yes. Now coming to what is the meaning of this. Terms of a sequence are denoted by A1, A2, A3, A4, A5. So last term. So there is no terms here. This is last one. If I mentioned dotted means, yes, infinitely number of terms are there. If I mentioned dotted, so here there is no dots. Means yes, full stop here. I mean last term. That is nth term. That is equal to 19 in this progression. Now, why it is called progression? You see the definition here. Yes, 1, 3. We don't know. Suppose we don't know. This 3 we don't know. Yes, we have to fill this one. Second term we don't know. As what its preceding term, preceding means as behind the term. As what is the previous term of this one, that is preceding term 1. By adding 2 to the its preceding term, we'll get the term. Just by adding 2 to its preceding term, that is a2 is equal to, as what its preceding term, that is a1 plus 2. What is the value of a1? 1 plus 2 is equal to 3. This is very important. So the obtained, I mean succeeding terms are obtained. Very important. Very important this one. So succeeding term is obtained by adding to its preceding term. As suppose we don't know this term, that is a3 we don't know. So a3 is equal to what is preceding term? As a2 is the preceding term. Yes, what is the rule here? As we should add 2. Yes, that is equal to a2 means we got here 3 plus 2 is equal to 5. So this is called progression. Suppose we don't know this one, we don't know. Suppose 1, 2, 3, 4, 5, sixth term we don't know. Yes, this is 3, this is 5. So sixth term we don't know. For example, sixth term we don't know. What is preceding term? 9. Yes, what is the rule here? 2, adding 2. So 9 plus 2, like this. So in this sequence, the succeeding term is obtained in this progression or in this sequence. The succeeding term is obtained by adding 2 to its means what you have to calculate. Suppose we are going to calculate 1, 2, 3, 4, 5, 6. We are going to calculate a6 to its preceding term. Preceding term is a5. Suppose we are calculating a7. What is preceding term? That is a6 plus 2. Suppose we are calculating a10. What is preceding term? That is a9 plus 2. Then we will get the succeeding term of the preceding term. So each term of a succeeding term is obtained by adding to its preceding term, then you will get the succeeding. So this is called as progression. So I mean, what is the meaning of progression? Progression is a group of numbers are arranged in a particular manner, or in a particular pattern, or according to a definite rule. That is very important. A group of numbers are arranged according to a definite rule. Group of numbers, note down please a definition. Group of numbers, definition or meaning as group of numbers are arranged. Group of numbers are arranged according to a definite rule. Then the group of numbers is called as progression. Is called progression. Is also called, I told you, sequence. Yes, what is the meaning of sequence? Sequence is a group of numbers arranged according to a definite rule. This is very important. According to a definite rule, and the numbers of a sequence are called as terms. Numbers. So these are all called terms of a sequence. So first term, that is 1, denoted by a1 is equal to 1, a2 is equal to 3, a3 is equal to third term 5, a4 is equal to 7, last 10, a10 is equal to 90. So last term, that is very important. So if it is the last term denoted by an, if dot represents as infinite number of there, then we cannot write the last term or an. Yes, this is the last term of this sequence or this progression, that is a10 is equal to 19, denoted by an. So an is also called as nth term. So numbers of a sequence are called as terms. That is very important. Let's see different types of examples. Yes, what is the meaning of progression? Progression is a group of numbers, or sequence is a group of numbers arranged according to a definite rule. According to a definite rule, then it is called as progression or sequence. Let's see different examples. As first one, next 4, next 9, next 16, next 25, next 36, next 49. Can you guess the next term? That's 64. That's next term 81. Next term 100. Next term 121. Yes. So how can you say the succeeding term? That's very simple. These are all square of the natural numbers. 1 square 1, 2 square 2, 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 14, 9 and so on. So this is also one of the rule followed in this progression or sequence. What is the rule here? So the rule is square of the natural numbers. So this is one type of rule. As next, as for example, as 100, sorry 1000 you write, no problem. Then 500, as 250, then 125, yes, and so on. Yes, what is the rule here? So these numbers are arranged in a particular manner. We should find that rule as first 1000. So how will you get 500? As 1000, yes, into 1 by 2. Into 1 by 2 or divided by 2, that is 500. So how will you get succeeding term? What is previous term? 100. Multiply by 1 by 2, that is 250. So how will you get next term? What is preceding term? 250. Again multiply this one by 1 by 2, that is 125. So similarly 1 by 1. So this is also example for sequence or progression. So in this group also the numbers are arranged in a particular manner or according to a definite rule. Let's see another example. As 2, 2, 4, 8, next 16, 32, 64, 128, 256, 512, 1024, 2048 and so on. Yes, can you say what is the rule here? Yes. How will you get the succeeding term? Yes. What is the previous term of this one? Supposed to multiply by 2. Square, multiply by 2 continuously. So yes, 2 into 2, 4. 4 into 2, 8. 8 2 is 16. 16 2 is 32. 64. 2 is 128. 2 is 256. Into 2, 512. Into 2, 1024. Into 2, 2058. So succeeding term of this progression is obtained by multiplying to its previous term. To its previous term. Suppose we don't know this one. As what is the preceding term of this one? 2. Multiplying by 2. 2 into 2, 4. Next, we don't know this one. As what its previous term? 4. Multiply by 2. That is 8. Similarly, 1 by 1. So what is the rule here? The rule is multiply by 2. So here, multiply by 1 by 2. Here, as making square. Making square. So these are the rules. Not only this, many are there. So totally the conclusion is progression or sequence is a group of numbers arranged according to a definite rule. According to a definite rule, then it is called as progression or then it is called as sequences. Okay na? Yes, today's class, what you have studied, what you have learned. So what is the meaning of progression or sequence? So progression is a group of numbers are arranged in a specific rule or in a particular manner or according to a definite rule, then the group of numbers are called as progressions, is also called as sequences. As tomorrow we shall discuss about the very important first one, what is the meaning of arithmetic progression or arithmetic sequences. Today's class is very important. I told you earlier, so there is a connectivity between one class to another class. Please don't miss, compulsory, you must watch all the videos. So this is not so easy lesson. So difficult to understand, no problem, nothing to worry, I will clarify your doubts. Okay, I shall continue in the next video class. Yes, thank you.